Good afternoon, everybody. I welcome you all to my channel on basic chemistry. Today's topic is on hybridization, part 1. Here I shall tell you about the concept of hybridization and its prediction. How to predict the type of hybridization in different molecules. Let me tell you first the concept. First one is mythological concept. In mythological concept, though it is not accepted, I want to tell you that there are certain words like Narasimha, which is man lion. It's due to the combination of man with lion. In hybridization, the things which are to be mixed should have nearly comparable energy. But man and lion, they are of different energy. Hence, in mythology, though we heard about Narasimha, but in my opinion, it is to be discarded. We heard about Sarpakanya, which is a serpent woman. Serpent woman, which is due to the combination of a serpent with human. This is also a mythological concept, but in my opinion, this has to be discarded. We also heard about Matsya Kanya, fish woman, which is a combination of fish with women. They are also having different energy, hence it is to be discarded. In mythological concept, I have told you about the words that I have heard about Narasimha, man lion, about Sarpa Kanya, serpent woman, about Matsya Kanya, fish woman. But they are not of comparable energy. The energy between these things, man and lion, serpent and woman, fish and woman, there is a large difference. Hence, it can't be called that the product is due to hybridization. Now, I shall tell you botanical concept. In the market, that we get a different type of fruits which are highly dazzling, good looking, like guava, papaya, and different type of fruits. They are due to the hybridization. These fruits are of bigger size, and also I want to tell you that the rose flower, if we combine a red rose with yellow rose, the product is a hybrid. The product is a hybrid. It may be pink in color. It's not that half portion is red and half portion is yellow. It's totally a different color. Similarly in botany, almost all flowers, all fruits, they are due to hybridization. Now I shall tell you geological concept. We have heard about mule, which is a combination of horse with female donkey. Mule is a product which can carry load like that of a donkey and it can run like that of horse. We heard about the mule and it is existing in our earth. We also heard about, we have seen in Animal Planet and National Geography, like by combining lion with a tigress, we get liger. Liger is a hybrid. Mule is a hybrid. Also we can say, suppose a man from UP shall marry to a woman from America, then the product we may call it's a hybrid. It's all about geological concept. Now our point of discussion is chemical. I mean hybridization from chemical point of view, that is in chemistry. Chemical concept means what is hybridization from chemical point of view or in chemistry. Here we shall mix orbitals. Orbitals which are having nearly same energy, not exactly same energy. Nearly same energy orbitals are to be mixed. The number of orbitals which are to be mixed, it will give rise to the same number of hybrid orbitals. I shall tell you details when I shall tell you in part 2 about the different compounds. But after concept, I want to tell you prediction. In predicting the type of hybridization with the central atom of the compound, what we have to do? First point is find out the total number of valence electrons. Find out the total number of valence electrons. This is the first criteria. Now the second point is, if it is a cation, then subtract the number of cations, the number of positive charges, and if it is an anion, add the number of negative charges. It will be more clear when I shall explain the different examples. The third point is, if the number is equal to or less than 8, the number is equal to or less than 8, then divide it by 2. The total number of valence electron, if it is 8 or less than 8, then divide it by 2. If the remainder still remains, then you have to divide it by 2 again. On the other hand, if the number of valence electrons is between 9 to 56, 9 to 56, then what you have to do? You have to divide by 8. Then if the remainder remains, divide it by 2. Now what will be the result? The number is first quotient Q1, and if other quotients are still there, then plus Q2. Then first remainder you will not take into account, rather the last quotient R2. So first quotient R1, if it is to be divided again, then second quotient Q2, and then the last remainder R2. That will give rise to a number. If the number is N, if it is 2, then it is SP. If it is 3, then SP2. If it is 4, then SP3. If it is 5, then SP3D. If it is 6, then SP3D2. If it is 7, then it is SP3D3. Is it clear? By combining Q1, and if at all Q2 is there, and then the last remainder, you have to get the number N. If N is equal to 2, then it is SP hybridization. N is equal to 3, SP2. N is equal to 4, SP3. N is equal to 5, SP3D. N is equal to 6, SP3D2. N is equal to 7, SP3D3. But it will be more clear when I shall tell you the examples. I shall tell you some 8 to 9 numbers of examples which are there in your course. This portion is important from 11th class point of view. where hybridization is there in chemical bonding. It is also important from 12th class point of view, where it is there in the chapter coordination compound under the head valence bond theory. It is also important in zero group elements, where you are supposed to determine the structure of a xenon difluoride, xenon tetrafluoride and xenon hexafluoride. This topic is important, and above all, in the engineering and medical entrance examination, questions are likely to come on hybridization. Like in inorganic chemistry, chemical bonding, atomic structure and a periodic table are the backbone of inorganic chemistry. Similarly, in chemical bonding, hybridization is the backbone, is the point of importance. Now, let me tell you, for methane, formula is CH4. This is methane. We have to find out the total number of valence electrons. Then we have to say what type of hybridization is there. In carbon, its atom number is 6 and number of valence electrons for carbon are 4. Hydrogen is in group 1 of the periodic table. It has atom number 1 and number of valence electrons is 1. For 4 hydrogen atoms, it is 4. So total number of valence electrons are 8. Is it clear? Carbon is in group 4 of the periodic table, having atom number 6, and it has valence electrons 4, 1s2, 2s2, 2p2. So in the outermost shell, 4 number of electrons are there. And in hydrogen, 1 electron is there. For 4 hydrogen atoms, 4 electron. So total is 8. Now, total number of valence electrons is 8. What I have to do? I have to divide it by 2. It is becoming 4. So the type of hybridization is sp3. Because when the number comes 4, the hybridization is sp3. Is it clear? Now, let me tell you. For C2H4, which is ethylene or ethene. Let us see what type of hybridization is there. Here, carbon has 4 electrons in its outermost orbit. For 2 carbon atom, the total number of electrons are 8 plus. For 4 hydrogen atoms, it is 4. The total number is 4. Now, as the number exceeds 8, we have to divide it by 8. 1 comes as the quotient and the remainder is 4. Divide by 2, the result is 2. The total number of valence electrons for ethylene is 12. 8 for 2 carbon atoms, 4 for 4 hydrogen atoms. The total number is 4. As the number is more than 8, I have to divide by 8. It comes out quotient is 1 and the remainder was 4. I divided it by 2, the result is 2. So 1 plus 2 is equal to 3. Hence in ethylene, the hybridization is sp2. Is it clear? In ethylene, the hybridization is sp2. I have told you just before, in methane it is sp3, and in ethylene it is sp2. Now, for C2H2, the compound is called ethine. It is also called as acetylene. Let me calculate the total number of valence electrons. It is carbon has 4. So for 2 carbon atoms, it is 8. For 2 hydrogen atoms, 2. Total number is 10. Hence, I have to divide it by 8. The quotient is 1. Then the remainder was 2. I shall divide by 2. The quotient is 1 and the remainder is 0. See, for carbon, 4 electrons, for 2 carbons 8, for 2 hydrogens 2, the total number of electrons are 10. I am divided by 8. The quotient is 1 and the remainder is 2. I shall divide by 2 again. The quotient is 1 and the remainder is 0. So the result is 1 plus 1 plus 0, that is equal to 2. As the value of n is 2, it is Sp. It is Sp. So for C2H2, the hybridization is Sp. Now, so Sp3 hybridization we find in CH4 methane. Sp2 hybridization we find in ethylene or C2H4. Sp hybridization we find in acetylene or C2H2. Now I shall tell you about NH3. NH3 is ammonia. Nitrogen is in group 50 of the periodic table, having atomic number 7. It has electronic configuration 1s2, 2s2, 2p3. So number of electrons in the valence shell is 5. So 5 plus. Hydrogen has 1 valence electron for 3 hydrogen atom 3. So total number of valence electrons is 8. As the number is exactly 8 or less than 8, if it is, then we have to divide it by 2. The result is 4 and the remainder is 0. So 4 plus 0 is 4. Now, as the value of n is 4, it is sp3 hybridization. In ammonia, the type of hybridization is sp3. Is it clear? Now, I shall tell you about H2O. This is water. Hydrogen has 1 valence electron. For 2 hydrogen atom, it is 2. Oxygen is present in group 6A or 16 of the periodic table. Having atom number 8, electronic configuration is 1s2, 2s2, 2p4. It has 6 electrons in the valence shell. So plus 6, total is coming 8. So as the number is 8, I shall divide by 2. The value is coming 4. Hence it is sp3 hybridization. Is it clear? So far I have told you methane, ethylene, acetylene, ammonia, water. Let me tell you some more examples. Let me tell you, for ammonium ion, nitrogen has atom number 7, number of electrons in the outermost orbit is 5. For hydrogen 1, for 4 hydrogen atoms 4. Now, total number of valence electron is 9. 5 plus 4, 9. Now, as it is positive charge and 1 positive charge, so let me subtract 1, the result is 8. Hence, I have to divide it by 2. I shall get 4. So it is sp3 hybridization. Now I shall tell you about sulfate ion, SO42 minus. Sulfur is in group 6Ar16, oxygen in group 6Ar16. Hence, the number of valence electrons for sulfur is 6, for oxygen is 6, for 4 number of oxygen atoms into 4, total is 6 plus 24, it's 30. 6 plus 24, 30. Now the two charges are there, negative charges. I have to add plus 2. The number is coming 32. So what we have to do? We have to divide by 8. The result is 4, quotient is 4 and the remainder is 0. No remainder is there. So 4 is the number, hence it is sp3 hybridization. 32 divided by 8, it's coming 4. No remainder is there. So there is no need of dividing it further. Hence the value is 4, hence it is sp3 hybridization. Now let me tell you, for nitrate ion, NO3 minus. Nitrogen has valence electron 5, oxygen has 6, plus 3 number of oxygen atoms, so total coming 23. Now 1 negative charge there, that I shall add 1, so the value is 24. I have to divide it by 8, the number is coming 3, so it is sp2. Is it clear? I am repeating it again. Nitrogen has 5 number of electrons in the valence shell, oxygen has 6, so 6 into 3, 18, 18 plus 5, 23, 1 negative charge there plus 1, total number is 24. I have to divide by 8, the number is coming 3, so it is sp2 hybridization. Now let me tell you, for nitrite ion, NO2 minus, again 5, 6 into 2, so total is 17. For 1 negative charge plus 1, that is equal to 18. Is it clear? For nitrogen 5, 6 into 2, 12 plus 5, 17, plus 1 negative charge plus 1, so 18. Hence I have to divide by 8. The quotient Q1 is 2 and the remainder is 2. I have to divide by 2, the result is 1. and the remainder is 0. See, the number of valence electrons are 18. I have to divide by 8. The quotient is 2 and the remainder is 2. For the remainder, I shall divide by 2. It is coming 1. So Q1 plus R1. So it is coming 2 plus 1 is equal to 3. Hence it is sp2 hybridization. sp2 hybridization. So some ions like sulfate ion, nitrate ion, I have told you how to determine hybridization. Now for BCl3 is boron trichloride. Boron has atom number 5, 1s2, 2s2, 2p1. Number of valence electrons is 3 plus. Chlorine is in group 7a of the periodic table with the halogens. It has 7 electrons. So total number of electrons are 7 into 3. 3 plus 21, 24. Number is 24. I have to divide it by 8. The quotient is 3 and there is no remainder, hence 3 is the number. The result is sp2. Now I shall tell you for beryllium fluoride. Beryllium has atom number 4. Valence electrons are 2. Hydrogen, helium, lithium, beryllium 4 atom number. Electron configuration is 1s2, 2s2, so 2 number of electrons are there in the valence shell. Fluorine has 7 electrons into 2, so 2 into 14 is 16 number of electrons. The total number of electrons is 16. What I have to do? I have to divide by 8. The number is coming 2. And no remainder is there. So it is sp hybridization. Now some difficult ones I shall tell you. Xenon fluoride. Xenon is in group 0 of the periodic table, group 18. It has 8 electrons in its outermost orbit. Fluorine has 7 for 2 fluorine atoms. So 8 plus 14, 22. Hence, I shall divide by 2, 8. 2 is the quotient. Then the remainder is 6. I shall divide by 2. It is coming 3. And no remainder. See, total number of electrons 8 plus 14, 22. As the number is more than 8, I shall divide by 8. The first quotient is 2. 6 is the remainder. I have divided by 2. And the remainder is, and the quotient is 3. There is no remainder. So 2 plus 3, 5 is the result. Hence, it is sp3d. See, this question used to come in the board exam, in the entrance examination. For a xenon difluoride, it is sp3d. Similarly, we can find out for a xenon tetrafluoride, it's 8 plus 7 into 4. Total is 8 plus 28 is 36. Is it clear? 8 number, here 7 into 4, 28. So 36, I have divided by 8. The quotient is 4. The remainder was 4. I have to divide by 2. So 2 is the quotient and no remainder. So 4 plus 2, 6 is the number. Hence, the hybridization is sp3d2. Is it clear? Now, for general hexafluoride, it is 8, 7 into 6. So 8 plus 42, that is equal to 50, the total number of electrons. Hence, I have to divide by 8. The quotient is 6. 2 is the remainder. I have to divide by 2. So it is 1. So 6 plus 1, 7 is the number. Hence, it is sp3d3. Is the type of hybridization in general hexafluoride. I hope I have told you many examples in the determination of hybridization. Let me tell you 3 more examples. For PCl5 phosphorus pentachloride, phosphorus is in group 15 of the periodic table, nitrogen, phosphorus, arsenic, antimony, bismuth. So phosphorus has 5 electrons in the outermost orbit. Chlorine has 7 into 5. 5 plus 35 is equal to 40. Let me divide by 8. So number is 5 and no remainder. So it is sp3d. The type of hybridization in PCl5 phosphorus pentachloride, the type of hybridization is sp3d. Now for IF7, iodine heptafluoride, it is 7 plus 7 into 7. So 7 into 49 plus 49, number is 56. Divide by 8. 7 is the number. So the type of hybridization is sp3d3. And one last example. Sulfur hexafluoride. Sulfur has 6. Fluorine has 7 into 6. So 48. Divide by 8. The result is 6. No remainder. So sp3d2 is the type of hybridization in sulfur hexafluoride. I hope it is clear. I have told you almost all examples that is in your book and the questions which used to come in the exam. So hybridization part 1 regarding concept and prediction of hybridization. I hope my teaching is clear. If you like, then you subscribe. Thank you all. Thank you.